So here we're going to put pretty much everything together, and there's various things we can do. We can solve for basically any side or angle of a right triangle as long as we have two pieces of information about the triangle. So for number one here in 15b.3, this is again asking you to find the measures of each of those angles. So take a moment, pause the video, and see if you can set up each of the trig functions that relate in reference, right? So in reference to the angle we're trying to solve for, and with the given sides, which trig function you would use, and see if you can set it up, and then I'll have the way you would type it in the calculator on the board. So take a look here and see if you've identified the correct ratios. So notice for that first one, you have the adjacent and the hypotenuse. So cosine would be the function that you would set up, the relationship you'd set up using those two sides, but then you'd have to use the inverse cosine because we are solving for the angle, right? So you can type that into your calculator and write it down to 3 sig figs. Check it in your book if you need to. For the second part B, we have the opposite and the hypotenuse. That is the sine function. Right? Sine of theta equals 3/4. But again, you have to use the inverse sine to then solve for the angle. And remember, that's in degrees, right? The angles we are calculating are in degrees. Last one is tangent, right? So then inverse tangent of 6/7 to solve for that angle. So we're going to take a look at putting all of those pieces together. So Pythagorean theorem and then our trig functions to help us solve the right triangle. And when we say solve, that just means solve for the missing values. So that means we have two sides, right? Two sides to solve for and a missing angle. So right away, I can solve for that missing angle really quick. I know this is a right angle. This is 35. So 90 plus 35 is 125. And I know that there are 180 degrees in a right triangle. So in a triangle, period. 180 minus 25 is equal to 55 degrees. So I didn't have to do any of my trig functions. That was just using the fact that there are 180 degrees in a triangle. There you go, right? So measure of that angle is 55 degrees. Now at this point, we do need to solve for the sides. So this goes back to setting up some trig functions. And at this point, because we didn't have to round 55, that is an exact answer that would be okay to use in this calculation. I like to always stick with the information I'm given. So I'm going to reference the 35, and I'm going to set up a couple trig functions to solve for x and y. So to solve for x is the side opposite, and the 5 is the hypotenuse. So just as before, this is what we've done before. We're just putting it all together to help us solve for any missing piece. So that means I can use sine. So sine of 35 is equal to x over 5. And again, we'd have to rearrange that to solve for x. Notice I'm not going to use the inverse. I'm solving for a side. So there's no inverse function needed here. I just need to rearrange this to get x by itself. So x equals 5 sine of 35. So whatever that turns out to be, there you go. That is x. And we can set up another trig function in regarding y. So now y is the adjacent side in relation to the angle I'm using, which is 35. So adjacent and hypotenuse, that is cosine. So cosine of 35 equals y over 5. Again, the solving is very similar to what we just did. I got to multiply both sides by 5. And then I get y equals 5 cosine 35. Again, I can type that into my calculator and write down my answers. Generally, it doesn't say here, but generally you either see one decimal place or two decimal places or three sig figs. Just be consistent if you're not told. So three sig figs is fine. A decimal place is fine. There you go. Right. So that's all of the missing sides. We had to solve for an angle and we had to solve for two sides.